My name is Peter. So today I'll be taking you on a topic that we mostly don't hear about whenever we are in a Web3 event. And today I'll be talking about Cosmos ecosystem. I'll basically be looking at the interchain. I'll discuss more about Cosmos ecosystem and the IBC. We'll talk about interoperability. We'll talk about app chains. We'll talk a lot about the Cosmos ecosystem. And most of you must have heard of the interchain, the Internet of Blockchains. So, first of all, I'll go through the basics of Interchain and its tech. Then I'll look at how IBC works, some similarities and differences with Ethereum, and then the use cases and real-world examples, and exactly why am I speaking about interchain applications today. So this is the slide. In case you want to follow through with your mobile phones, you can scan it, and then you can see it from there. Okay, so if you scan it, you can also give it to your neighbor to scan from there. So we can see the interchain, or we can think of it as a galaxy, all right? In the interchain there, it's a network of interconnected blockchains, each implemented with specific properties. We can say that app chains that are developed in the interchain are application specific. They are purpose built. And that is the main component of the interchain. No. It's not a slide. So the concept of hubs and zones were one of the initial concepts of the interchain. But although this is not particularly what we have, but we can think of the hub as an interoperability layer. A hub is a blockchain, just like an Ethereum, all right? And a zone is also a blockchain in the app chain context, in the interchain context. But then the hubs are regarded as bridges. Think of it as bridges that facilitate communication between zones. These zones are specific app chains, and these zones are purpose built and are app specific. So these hubs allow interoperability. They allow these zones, as you can see here, this is a zone and this is a hub. The Cosmos Hub is the first hub or the first blockchain in the interchain. And the Cosmos Hub allows or facilitates transactions and communications between interconnected zones. And then one of the most important thing about the interchain is the IBC, the Inter-Blockchain Communication Protocol. This helps, or this is one of the key enabler of interoperability between these app-specific chains in the internet. How do these chains communicate, transfer assets and data with each other? It is via the IBC protocol. And we can say that app chains in Cosmos are built with the Cosmos SDK. So I like to think of this as the interplanetary stuff, all right? We have a galaxy, and in the galaxy we have systems, all right? We are currently in the solar system, and the star of the solar system is the sun. And revolving around the sun are planets, all right? So we can think of the interchain as being a galaxy that has several app chains, and then each of these app chains contains or is being built with the Cosmos SDK, and this Cosmos SDK has several models. These models each have specific functionalities that they offer for the app chain. So for example, if you're building an app specific chain, you can add some of these models: the bank, the auth, the stake, golf params, mint, OTZ, and more of them. There are several models. Or as a developer, you can also develop your own custom model for this blockchain. So let me go deeper into models. When you're building an application with the Cosmos SDK, models are like the most important thing, and transactions are routed to a specific model to handle it. This is a simple message or a message sent. That's a normal transfer of tokens in a Cosmos chain. And then the way this happens is that you encode a message as a transaction and you send it to an app chain. In this message, there is a type URL, this, all right? This defines the interface, all right, on which exact model in the app chain that this encoded message will be routed to. This model has keepers and multi-store, and this keepers manages account and states in the model. So if you are sending this message to a Cosmos chain, all right, you are basically sending it as a transaction, and then the type URL is defining the interface or defining the type of where the model will be, the transaction, the encoded message will be executed inside the model. And if there is state in the model, the keeper manages access to it. And the multi-store is like a key value storage that holds the states in a Cosmos model. I know this might be a lot, but let's go on. So let's talk about the IBC protocol. I briefly mentioned that it is what powers interoperability in the Cosmos chain. So basically, what the IBC is it is the HTTP. Think of it as HTTP of the interchain. It's basically the protocol that handles the transport of data between app chains in the interchain. And then TLDR, too long to read, IBC powers cross-chain communication. So we look at how IBC works in the next slides. There are clients, connection channels, and ports. And there is another thing called packets. A client, a Tendermint client, is basically a client that helps to keep track of the consensus states of several app chains. All right. If it keeps the consensus state of an app chain, and then when you create a connection between two endpoints, that's between an app chain and an app chain, the client can be able to verify it with something known as proof spec. Now, the channel can be bound to any port, and these ports are like, normal ports, like if you're developing on localhost, there's a port. So these ports are like a port that is being bound on an end. And then when you open up a channel, you can be able to transfer assets between two app chains. And basically, this is how the IBC works. It has clients, which is basically to verify the state and using something known as proof spec. And then there are connections between these two app chains. And then there is a channel that you can open up between this, you can open up in this channel and bound the channel to a port. And what you can send between these two app chains is known as packets. So one of the differences with the Cosmos and EVM is usually the consensus, but basically they are both proof of stake. But then Cosmos has the Tendermint consensus. Ignore this. Tendermint or BFT. Common BFT is more like a rebranded version of Tendermint. And then there is Entermint, which is a fork of Tendermint to introduce a model, an EVM model, in the Cosmos consensus, which would allow you to have EVM compatibility for your app chains. So it's basically adding a drop of EVM. So normally in Cosmos, you have the Cosmos EVM, and then if you want to add, if you want to make your app compatible with EVM, you use the Entermint consensus client. Basically, the consensus client in Cosmos, it has the ABCI and the engine. So the engine is like the consensus engine, and then the ABCI is the application binary interface that helps the consensus to interact with your application. The ABCI is more like a language independent, like it's not particularly tied to any language. That way it can be able to talk to your application directly. So those are the two main components of the Tendermint consensus. It has the engine and the application binary interface, ABCI. Okay. So I'll quickly talk about the accounts. In normal Ethereum environment, basically in Cosmos, the same account model is being used, the same public key cryptography, but what is different is the hashing algorithms and the algorithms are being used. So in order to generate the address of a Cosmos chain, you have to use the RIP-EMD 160, which is a 160-bit hashing algorithm, compared to the EVM, which is a 256-bit hashing algorithm. So it has a prefix. This prefix is a chain. For example, Noble. Noble is a blockchain. All right. Osmosis is also another chain. Like 2 minutes. Okay, let me round up. So basically, in Cosmos account, you still use the same public key cryptography. You can make use of SEP256K1, R1, or Edwards curve for accounts there, but mostly the most popular one is the Koblitz curve. And then this is how the account is generated. And basically, this is all part of the account object. An account object contains the base account, which contains the address, public key, and sequence. I want to talk about that now.
Oh, amazing. Awesome.
I was going to talk about examples, but
thank you very much for that awesome session. Thank you so much.
All right, so this is my social. If there is any.
Thank you so much, Peter. Please, a round of applause for Peter.